With my presentation. Today I will be talking about mapping, visualization, and beyond, geospatial analysis in landscape archaeology. Uh, I will be primarily talking about maps, historical maps, and mapping, and then understanding archaeological sites and landscape using remote sensing data and GIS. And then I will discuss two case studies. We have maps. If we talk about early maps, so proper maps, like I would say, scientific maps started coming from the classical era. So this is one of the earliest maps, Ptolemy's world map, which depicts the entire world, but in a crude form. But it was very scientific at that time. So these maps gives us some historical information about some certain sites which were known then. And then, the map making did not progress much till I would say like the age of discovery. And we find like before that, we find some maps, some Arabic maps. They are also based on previous maps. So again, they are useful, but yeah, not that much because the accuracy was not too great. And they were mostly based on travelers' accounts, not was done through land surveys. Why I'm talking about these maps, because these maps contains information. So I will be talking about the maps which were produced later, during and after age of discovery, when people started exploring land all over the world. And then these maps becomes important source of information about archaeological sites as well as about geomorphology of the area. So, and that is why they become very important. And remote sensing, what remote sensing does, it gives us confidence in the content of these maps. So that is why we integrate early maps using GIS, and we also use remote sensing data to validate the content and then use it for several purposes, like to investigate, to explore some archaeological sites, to understand landscape, to understand landscape particularly. I mean, if we talk about India, so the mapping started taking place for the coastal regions first, because these people, the colonial power, they came through coast, and because they first entered the coastal area, so they started mapping the coast first. So we find lots of maps of coastal India, particularly from 16th centuries onwards. So first Portuguese came, they mapped, and then Dutch, then French, British, and Danish. So we have maps made by these people, and there are, I think, over thousands of maps available in various archives and libraries uh, in India and across the world. So they are they have huge potential for archaeological investigation. I will just show few examples of such maps and paintings, which could be really useful in archaeology. And then I will tell how this can be studied using remote sensing. So because these paintings and views and maps are geographical information, which can be integrated in GIS and then can be used for archaeological research. So this is one example of oblique view, or a bird's eye view of Goa. So here like terrain is represented very well, and you can see a lot of buildings which can be identified on ground even now. Like some of the buildings can be, because we cannot just believe in these maps blindly. We have to understand the errors in these maps, which I will be briefly discussing in later slides. But in short, these maps contains these very detailed information about older buildings and the topography. So here is another this painting of Koldam Fort, and today we see only this turret is left, and this bastion is gone. But these paintings again, like if we integrate with maps and other records, helps us in reconstructing the past buildings, landscapes. Here is the example of uh, plan maps. So these are very detailed maps. Again, they can be used to uh, trace some of the remains of these forts, which are now completely in ruin or are completely in dilapidated conditions. This is another example of Bombay Fort, which is clearly seen in this map. But if you look at today's satellite image, or if you go to this site, you won't find all these remains. But these old maps preserve the old fortification, so we can understand how it was built. And then we have small scale maps. Small scale maps covers larger area and can be used to understand larger features like rivers, coastline, like maybe some islands, and multiple sites and their relative positions. And in some in cases, they can be really useful to understand trade network, because these some of these old maps mention old trade network, so they are useful for that. So here it's a detailed view of this map, and you can see river. So if a river has changed its course in 100 to 100 years, a few centuries, we can understand that, and hence we can understand relative position of a site relative to a river or a coast. Then we have large scale maps which cover smaller area, but in great detail. So again, this is an example of Bombay Fort and its surrounding, and you can see the coast very depicted very well in this map. Also, some of the coastal features like shoals are mapped in quite detail. So these can be useful in understanding if a shoreline has changed or not, and its relation with the site. Then we have topo sheets, and these are very useful. So these topo sheets marks old sites as a cross and sometimes in form line. Like this one, if you see, this is a topo sheet of Gujarat. This is published in 1870s. So this area, I think my pointer would be visible to you. So this is actually Lothal. But in this map, because Lothal was discovered later in 20th century, and this is in 19th century map, it is marked as a mound here. So yeah, it is correct, better visible here. So sometimes these mounds form lines and uh, that X sign, which I have not mentioned in this one, but there are locations where they just mark cross. So those are old sites. So these sites help in understanding or locating old sites. And when you visit these sites, I mean, we have tried here a few sites, and we found a lot of potential sites using this information from these maps. And I would suggest you to read Cameron Petrie's and Hector Orango's paper. So they have done, I mean, they are using topo sheets of 19th and 20th centuries, and they are exploring larger area of Northwest India and Pakistan, and finding lots of sites, surveying and finding lots of archaeological sites. So uh, now I would ask you to look at this Google Earth image and see if you can see any pattern in this. I'll give you a few seconds to note that. If you find, I mean, you just remember that because I will be using this image again. So yeah, like try to find out a large pattern in this image. Okay, now I will talk about that image later. First, I want to discuss some critical aspects about historical maps, its error and accuracy. So because these maps are old and made for different reasons, so depending on the purpose for which they were made, their accuracy vary. So if somebody wants to use it for navigation purpose, the coastline, there are chances that coastlines are depicted much with better accuracy than the inland areas. And similarly, if it is meant for just for putting on a seal, as a painting, so the accuracy may not be that great. Then error of inclusion and exclusion. Sometimes they do not go to far distance and then check the place they notice from a far distance correctly, and they include something which is not there. And sometimes it happens they exclude, maybe by choice, and by because they have not done enough survey. So so again, like something which is not present in the map may not mean that it did not exist. It may not be of interest to the map maker, or they have not done enough survey to include that. And then when we talk about in terms of coastal areas, self similarity is another issue. So if you don't have scale in the map, it may sometimes be very difficult to actually find the extent of that map and locate it correctly. Then originality and temporal context, because uh, a map which is made now may be published, people actually in history, if we look at history of cartography, people were using older maps and publishing it at later dates. So again, the temporal context is very crucial to understand whether that map was original or it was reproduced from some older map. And then physical deformation. So if you remember the previous example where I showed topo sheet, the map was not in good condition. So there was some certain inaccuracy introduced by, because it was not kept well, or it was not in good shape. Then copying error. So people, when copying from one map to another map, they introduce human errors. And again, scale. So scale, I will tell you in the later slides. Scale conversion. So first we need to have uh, a scale marked in the map. If, like in most of the cases, you may not find these scales. And again, these are Dutch, French, and Danish maps. So it becomes difficult again to translate or understand the language and make the conversion. Anyways, a lot of these maps have a scale of importance. So if you see, this is a region in Kerala, in Chetwa. And this is again the same region, but the depiction is very different. However, if we want to extract information, we can, like, so this is a strip where Chetwa Fort is located, and it is surrounded by a water body. And here also this information. So sometimes we may not get cartomatically correct information from maps, but we can get certain qualitative information from them. So again, like while interpreting these maps, it's very important to understand. And this is a map of Kollam where this is a mirror image of the same. So it's a, like a error in reproduction. And like the text, everything is in correct form, but the entire the draft or the plan of the fort is reversed or mirror imaged. So if you find this one, not this one first, you may get confused where this fort is, and you may find difficulty in locating it. Uh, Now, this is the image which I showed you previously. I hope now you can find some pattern in it. If you have not found any pattern, probably this will help. Yeah, I think now the patterns would be better visible. So this is an example how like crop marks and satellite images can be useful. So because we had that map, so the importance of maps. So because we had that map, we could delineate this fort, and I'm not going to discuss that in detail in this talk. But tomorrow, Dr. M.B. Rajni will be discussing more about these patterns and how to identify archaeological sites with that. So, yeah, regarding the scale, this is an example where I have put uh, like outline of coastal features at different scales of map. This is the smallest scale map, this is medium, and this is bit larger. And you see in this map, the map maker has not shown it because because it covers very large area, so they have to show a lot of information. So they have not showed, but absence of this feature doesn't mean that this delta did not was not present at that time. And again, like the gap between these islands is better here, and I mean the width is different, so it is wider here, it is less wide here. like narrower here. But again, like so this is the license a cartographer take when they work on a different scale. So depending on what how much area they have to put their observations on map, based on that they decide what to include, what not. This is again like I quickly show you this example where this map shows this Tranquebar Fort and a river flows right next to it. But now we see a river goes like this. So one may think that river has migrated or like changed its course slightly, but we found another map of the same time, and it shows exactly like as how it is today. So again, like getting more and more maps, it's very important. You cannot rely on just one map. It's better to consult historical records as well when working with that, and also remote sensing data, which I will be discussing later how that helps. So uh, this is the first case study, Tamilabarni Delta. It's in Tamil Nadu, southern part of Tamil Nadu, below Thoothukudi. And this is important, archaeologically important, because site Korkai, which is an ancient port active around like 2000 years ago, is located 7 kilometer inland now. And this was very important port at that time, and this much progression has happened, or like sea regression has occurred in last 2000 years. And interestingly, there are other archaeologically important sites, other ports which became important later in 6th century, like Kayal port, and then which later became Palakayal. And then there is this Punne Kayal, which was active when Portuguese came. I mean, they made it a new port. And when Portuguese came in 16th century, the Kayal port was known as Pala Kayal, which means old lagoon. So, the because we had maps of this reason, we investigated, and these are two maps which are like smaller scale, I would say. And this one, if you look at this one, this whole area, the deltic area, looks like a lagoon, and like these are islands, and this big lagoon, and this is the location of Korkai port, Parlakayal. And in this map, this is a bit I would say a larger scale than this one, and it provides better details of the area at that time. And these channels have become much narrower, and this embayment kind of thing, now it doesn't look like that in this map, though they are of the same time. So it just the difference is because of the different scale, and the way these areas were mapped differently. So this is a sea chart, and this is a topographic map. So that is why like the emphasis was more on the lagoon and then access to these islands. So here in this one, it looks like a choked lagoons. These two lagoons are present, and this is the deltic area, and some spit is also visible. Now, we found another map, which is much larger scale, very detailed map. It's not visible, so I'm just superimposing what is depicted in this map. So this water body, these lagoons are depicted here in great detail. And actually, if we look at satellite image, we can trace these lagoons, paleo lagoons. And when we superimposed on this map, we could find field, we call that field patterns. So these field patterns and are following the shape of these lagoons, and we could actually very correctly locate them, the paleo lagoons and some of the paleo channels. I'll show you. I mean, this example shows how So this was in 18th century, and we do not have, if we do not have any information about 19th century, and this river or stream or any water body got dried at present. So we will see certain patterns. You can see here this pattern. So what we have now is just this map. So we have to rely on this map because it shows a water body and check if it was there. And with the help of these patterns, we can find out such paleo water bodies. So that's how we traced these lagoons and different channels. So if you see, this is that lagoon marked in this old map. And actually the agricultural boundaries follow this shape, so we could trace it very accurately, though we were not able to georeference because we could not find correct, like well defined ground control points, so we did not georeference. Instead, we actually superimposed and found out these traces and delineate these water bodies very correctly. So we found these lagoons in 1805 map and 1822 and 28 maps, and in within 100 years time, these water bodies got silted because we found another map of 1919 where these lagoons were not shown, and in this 1805 map. This was already having very narrow inlet to, the from the sea to the lagoons. So these were already choked lagoons. So because of less supply of seawater and interaction with the sea, they started silting, and also because of the input of sediments from Tamrabarni River to this area, it got silted. So this helped us in understanding. So another interesting point is this Palakayal. So and it was the Kayal port of which was mentioned in Marco Polo's account. So Kayal means lagoon, and if we look at the present image or present time landscape, we do not find this lagoon. So one may wonder why this is called Kayal. But using these maps and satellite images, we could explain the toponymy of this place. And again, this Kayal Patnam was probably named because there was this lagoon present behind this barrier strip. So this also, I mean, using digital elevation model, we use a simple bathtub inundation dam model where we just clubbed pixels with 0 to 8 meter depth in one shade, and then 9 to 12 in one shade, so that we understand how much what area will get underwater if this much level of seawater is raised. But I would like to mention here, because the topography in the past, like 2000 years back, would have been very different. So to make a correct model is really difficult, because it depends. So this feature, like Bayhead Delta and formation of the current landscape, has changed it a bit. So this model doesn't exactly show what it was like, but it gives us some idea like how much it would have got inundated. So there are studies which shows like around 6 to 4,000 years back, sea level was higher. So it is possible that at that time this whole embayment was present, and gradually when this river started bringing sediments and started forming this delta, it created this delta, and then because of sediment longshore transportation, coastal barriers were formed, and this enclosed this area, uh, and that's how these lagoons were gradually formed. And when this delta would have formed, this Korkai was the active port, and gradually when it was expanding, prograding towards the sea, and it became defunct, and then another port, Kayal, was established here. And then gradually this also became defunct because of sedimentation, rapid sedimentation in this area. And then this Pune Kayal and Kayalpatnam came into existence, and now this Tutukuri is the port here. So this is the present day image of this area. So, and this suggests the evolution, how it would have evolved, and how archaeological sites or location of ancient ports got affected in the past. Now, the second case study is of Lothal, and I'm sure that many of you know about Lothal. It's a Harappan site. It is considered as a maritime port town, and it is situated between these two rivers. This is very small River Bhogavo, and River Savarmati, which is around 20 kilometers east of Lothal at present. And So yeah. So this structure, this basin structure is of great interest, and some archaeologists they believe that it was a dockyard. This structure is dockyard, and this is the reconstruction based on S.R. Rao's uh, interpretation of Lothal. And so what we did, we tried to reconstruct the environment, the landscape around Lothal. This is one of the studies which was done in 2004, and this is the first study around Lothal which was done using remote sensing data. And here, Khatkikar and others they found a paleo channel, and they mentioned that it could be a paleo Bhogavo river which was connecting Lothal, and which supported S.R. Rao's hypothesis of Lothal being a port town and dockyard. I mean, that basin structure being a dockyard. So, what we did, we started uh, exploring the area much beyond this just this channel, and we looked at the larger extent of the area. So we explored this whole landscape using different data sets. I'm sure, like you had, I think last, like yesterday, you had lecture on microwave data, probably. So you have an understanding about the radar data and optical data, multispectral data. And so we used different types of optical data. We used Landsat data, Sentinel data, and then Sentinel radar data, microwave data, and then digital elevation model and historical maps. We integrated all this, and these are different image processing techniques we used. We use multiple methods because it enhances our chance to identify paleo channels. And since we have better methods to quickly, check this data, so we use that. This is what we did here. So we use one particular band of Landsat, that is shortwave infrared band, and it absorbs the like water absorbs this wave in this wavelength. So it becomes the paleo channels becomes, I mean, they are better visible in this wavelength. What we did, we used, I mean, we try to extract images of wetter years, of wetter I mean wetter months of wetter years, and then combine. So we found around 14 images from 1984 to till date, and we did PCA of that image, and then we found that it gave us really good results in finding out these paleo channels. And so this is a comparison of different methods versus this PCA of SWIR. Surely this one shows much better. So, and again, like because radar data, microwave data has its own advantage of identifying deeper buried channels. So we could also trace channels which were not visible from that SWIR method uh, by using this microwave region data. So, and then we also use these very high resolution images. These images are also useful to validate identification of paleo channels in other kinds of data, like using Landsat or Sentinel, because these are high resolution. We can find those field marks in these images, in high resolution images, very well. And also, it is seen that these water bodies are like which are around these small settlements, villages, and towns follow or are on some paleo channels. So that was also interesting to observe. And some paleo channels which was not visible in any other methods were visible better in Google Earth images. Google Earth also provides us multiple temporal images, though like right now I think they are not providing images before 2017. I mean, not that much earlier they used to provide. So yeah, and then after exploring or investigating the fluvial landscape around Lothal, we also explored coastal areas around Lothal. So it was, I mean, this seasonal composite sentinel data was used. And here you can see in this one, uh, okay, I'm sorry. I think my animation, I'm not able to see my animation on my screen, and perhaps I might be speaking before the animation slides appears. If that is the case, okay, I'll take care. I think, yeah, it might be confusing for you. I just realized that. So, yeah, this one, so this is an old map, and this is the present day landscape of Dholera Creek, and it is very narrow now. It is quite wide in this old map. And in this seasonal composite image of Sentinel data, we see this broad, dark color, which is corresponding to this creek depicted in this map. So again, this is validating. I mean, it's both way. So this is validating this maps information, and map is validating the patterns we are identifying in satellite images. So this helped us in demarcating these paleo creeks and paleo shoreline. Here we are showing that. So this is the present day creek, which is wide, and this is all tidal area, tidal marsh area. And if you look at this side, so it is. I mean, the study, our investigation suggests this shoreline would have been here, and this was similar to what it is like today here along the coast, this area. So it was probably like this. So this inundation is shown here, and this whole region would have been not suitable for to live. That is why we do not find any Harappan, Surat Harappan site in this area. So all these site, this area is devoid of any site at that time. So, and then, so this is the results of this study. So we could found lots of a paleo channel, which, so this paleo channel goes from Lothal to this Koth, another Harappan site, and it joins Sabarmati. So it became, I mean, through this study, it became clear that Sabarmati itself was flowing along the Lothal. And and we trace this coastline. I think it would be better visible in the next slide. Yeah, so these are different meander belts identified through the study. And you see here, so this is the meander belt, which would have, might be, I mean, most likely activate waited during the Harappan time. And we find lots of meanders here. Uh, and then these are different stages of river migration. And the Sabarmati River, at the end, it joined Vatrak and captured river Vatrak, and then flowing into Sabarmati. So the earlier course was like this, and Lothal was along its estuary. I think it will be more clear from this image. So here, I hope you are, because I am seeing the other image also on it. Okay. Anyways, so this is the uh, uh, river Sabarmati flowing along the Lothal. And uh, so if you see, this is like 15 kilometers inundated. I mean, the shoreline would have been that much inland at that time. And from there to Lothal, it is again like 15 kilometers distance. And the this the tidal effect at present of along the Sabarmati is up to 14 kilometer. And if we see here, like if this coastline was like this, so the effect would have been till Lothal at that time. So again, like it helps in understanding the entire process also. Yeah. So now I will zoom in near the Lothal. And so this is the Lothal dog. So SR Rao's report suggests that there are records of floods, severe floods during Harappan time, and at the end when this river migrated to east, so there was another inlet in the dock on the eastern side. So again, like the understanding based on excavation report is matching with our findings. So this is the reconstruction of Lothal by based on SRO's report, and this is what with this quote by Dr. M.V. Rajni. Like you are going to uh, have her talk tomorrow, and it says we must scavenge for traces of past human activity that have survived in material form and develop expertise in interrogating these materials before their secrets fade into oblivion. And this is one fort in Bangalore, and you can see how it was engulfed by construction of highways, expansion of